Hello, I'm on part 3 of my video series in the Blender game engine. In this video, I'm going to be showing you how to create a first-person shooter setup for the controls of your game. Now, what does that mean? Well, when you're playing a first-person shooter, you want to be able to control the motion of the camera in your game using your mouse. And with your left hand, if you're right-handed, you want to use the W and ASD keys to control the movement of your character. Moving forward, moving backward, left and right strafing. So I'm going to be showing you how to do that all in this video. Let's go ahead and get started. I'll click on the splash screen to get rid of it. And the first thing we have to do, of course, is change our render engine up here from the Cycles render engine over to the Blender game engine, which allows us to have more controls for our game. And if you press P on your keyboard with your mouse cursor in the 3D viewport, of course, you can play your game. So it's very important to change that over to Blender game. The first thing we have to do is we have to add left and right controls using our mouse to an object. Now, we're not going to be using the camera for a lot of the movement of our character. We're actually going to be using a cube, or really you can use any object, but a cube is good because it's simple. It's good for the collision bounds of a character, and it has a flat bottom, so we'll be using that. And what we want to be doing here is we want to isolate the left and right controls of your character away from the camera, which actually will be controlling the up and down looking of your character so that everything works properly, and you'll see why in a few minutes. Let's go ahead first and grab our cube, and I'll press G and I'll just move it straight up on the Z axis. So in fact, what I'll just do is grab that blue arrow on our gizmo and drag it straight up. I want to add a ground, so I'll press Shift A on my keyboard and select Mesh Plane. And what I'll do now is I'll press S and maybe 30, so S and then 30 and then Enter to make the ground much bigger. Let's go ahead and select our cube, which will again be our character, and I'm going to grab this little cross-hatched area and drag it straight down to divide my 3D viewport window into two, and I'll change this window type into a logic editor window over here using this little button on the header of your 3D viewport. Logic editor. If you haven't watched the last two videos in this series, I assume that you have, but if you haven't, you'll know that this window is where you actually create the programming for your game. It's where you add sensors and controllers, and I'm going to go ahead and press N on my keyboard and then scroll down or up to make that smaller, more zoomed out, and actuators. So sensors, controllers, and actuators, which are the building blocks of programming using these logic bricks. With the cube selected, I'm going to add a mouse sensor. We want to detect mouse movement on our screen. So add sensor and mouse. And of course, I'm not looking for the left button being pressed on my mouse. I want to select mouse movement. So now the sensor will detect when I'm moving my mouse around on my screen. Now, in the last video, I showed you how to create the complete look around. In other words, the first person controls, but everything we did was on the camera. And at the end of the last video, I explained that it's not good to put all of your controls on the camera because it allows you to accidentally go through the ground. If you're looking up and you press forward, that means you're going to be jumping unintentionally, and when you press backwards, that means you'll actually go straight through the ground because your local Z-axis on the camera is pointing down, so that's a bad thing. That's why we're isolating the left and right motion away from the up and down motion on your mouse so that your character will always stay flat on the ground, and there's actually some benefits here other than that as well. So with the cube selected, I've added a mouse sensor for mouse movement. I'm going to add an actuator. Yes, we are going to add a mouse look actuator. So add actuator mouse, and I'll change this mode to look. Now here's the thing about this mouse actuator. There are two columns, the X and the Y. And you might be thinking to yourself, hey, what about Z? Isn't this a 3D world? Are we making a 3D game where we have X, Y, and Z axes? Well, that's not what these two columns mean. These two columns mean the axes that your mouse is moving on your screen. And your screen is two-dimensional. It has two axes. Left and right is of course the X-axis, and of course up and down is the Y-axis. So that's what these two columns mean. Now, to make your character turn left and turn right, we only want to care about the X, the side-to-side axis of your mouse. So I'm going to click on this Use Y-axis to turn it off. It becomes grayed out. And so now this mouse actuator is only going to be using the left and right motion on your cube, which is what we want for left and right viewing. So now I'll connect my mouse sensor using this little port over to the port of the mouse actuator. And let's see what happens when I press P to play my game. So I'll press P on my keyboard with my mouse in this area, and if I move my mouse left, it points left, and right, it points right. If I want to change any options here, I'll press escape. You can do that over here. I can change the sensitivity right here. So if I turn this up, let's turn it up to maybe 4, and press enter, and I'll press P. It makes the motion quicker. So you can sort of specify that quite easily. One thing I forgot to do here though, is I forgot to change this object to be a physics object. So with the cube selected, I'll go over to the physics tab in the properties window. And in the last few videos, we've used 2 types of physics. We've used rigid body and dynamic. And those 2 options are great, but several versions ago in Blender, we got a new option called character. And this character option is fantastic if you're making a character for your game, as the name implies. When you select character, you get a few extra options. You get the option to have a step height. In other words, if your game has stairs, up until now, with dynamic or rigid body, stairs would stop you. Well, with this step height, you can actually walk up steps automatically without having to do any adjusting or having to jump every time with your character once you reach a step, and that's great. So I'm going to use character, and that will automatically fall down to the ground. So if I press P on my keyboard, he falls, and I can turn left and right. That's great. What I'm going to do next is I'm going to add the same mouse actuator, mouse sensor to the camera, but instead of having the camera move in all directions, it's only going to use the up and down motion of your mouse to look up and down, and then we're going to connect the camera to your character cube by simply parenting it. So with the camera selected, I'm going to add a sensor. Of course, it's going to be a mouse sensor. We're sensing for not the left button of your mouse, but we're looking for mouse movement. So whenever the mouse moves any direction, it'll become triggered. And once it's triggered, it's going to activate the actuator. So let's go ahead with the camera selected still. Let's add a mouse actuator. And of course, we have to use the look version of this. And instead of using both X and Y axes on your screen, of course, X and Y in 2D, we're only going to use the Y axis. So I'll hide the X one because X is being controlled by the cube. And let's take a look at what this option down here means. When you move your mouse up and down on the Y axis on your screen, it's going to control either the X axis rotation or the Y or the Z axes. So let's go ahead and see what that looks like. It's using the local, that's why this is dark right there. So let's go ahead and change our gizmo over to local. And so we can see now that if we want to move up and down or point this up and down, we have to rotate on the X, the red axes there locally, and that's exactly what this does automatically. So we don't have to change anything here. What I'll do though is I'll connect these 2 nodes. So I'll grab the little port there, click and drag to connect it to the input port using this noodle, and I'll let go. And so now if I press 0 on my numpad, or I go to view and camera, and then I press P on my keyboard, if I move a mouse up, it looks up, and down it looks down, and if I move my mouse to the right, it rotates the cube, and to the left it also rotates the cube, but now I want to connect these 2 things. So I'll press escape on my keyboard, and maybe I'll press 0 to go back just to a 3D view, and I'm going to go to my front view. So with my mouse in this window, I'll press 1 on my keyboard and then 5 to go into orthographic view, so front orthographic view with 1 and 5. Or you can of course go down to view and click on view persp ortho and then view front. As you can see, my camera is at a funny angle. I want to fix that. So with the camera selected, I'll press Alt R on my keyboard, and Alt R of course clears rotation. So now if I press 3 on my numpad, or go to the right view, that of course is view right, you can see now that we want to have the camera pointing in this direction. So from the side view, I'll press R and then -90, so -90, so that's R, -90, and then press enter. So now my camera is pointing in the same direction that my cube moves when I press forward. When I press W on my keyboard, it moves away from us, in other words, in this direction. So I want my camera to be pointing in that direction as well, which is the forward direction of the character. I'll go to my top view, and I'm going to move my camera to be above my character. So I'll press G and put it right about there. It doesn't have to be exactly lined up with the middle of the cube, but it's not a bad idea. You could also move it to be sort of at the front of the cube. I wouldn't put it inside the cube, but I would put it a little bit above the cube. That looks pretty good to me. So with the camera selected, I'll hold Shift on my keyboard. We're going to parent it to the cube. So I'll select the camera, hold Shift, select the cube, and then I'll press Control P on my keyboard. Control P is, of course, set parent to the second object that you selected. So Control P and then select Object. So now the camera, being a child of the parent cube, if you move the cube, the camera follows along. But being a child, the camera can also have its own movement, which is again controlled by the up and down movement of your mouse to rotate up and down on its local x-axis. So I'll press 0 on my keyboard to look through my camera, and I'll press P on my keyboard. So now I'm moving my character side to side using the x-axis on my mouse. You can see it sort of moving side to side. We'll make that more obvious in a minute. And I can look up and down with the x-axis, or rather the y-axis on my keyboard. That all works great. There's one really important thing that you have to make sure, if this is sort of glitching out on you, that you need to press. I'll press 0 to go back to my 3D viewport. On your cube, so I'll select my cube, you have a mouse look actuator, and it's really important that you have this reset option selected. In other words, it's dark. If you don't have it dark, and you try playing your game, so I'll press 0 and I'll press P, it will glitch out. It won't be able to move left and right properly when you have two different things, your camera and your cube or your character, using the same mouse motion. It just doesn't work. So you have to reset the mouse motion on your local z-axis on your cube to move left and right. That's really important that you have. In fact, I think it is by default on both the camera. Yes, they're both defaulted that way. So if you turn that off by accident, don't. It's really important to have. So I have movement, and that's great. Let's go ahead and set up the controls for the movement of my character. The cube is going to be the object that you're actually moving around, because the camera is the child of the cube, and the camera is only going to be there from looking up and down. So with my cube selected, I'm going to start naming these logic bricks. This mouse name, if I collapse this mouse name doesn't tell me very much about what this is doing. So I'm going to say mouse y-axis. Okay, so that's mouse movement, or maybe let's call that mouse movement. And I'll collapse that one. I'm going to name this one look up, down. That looks pretty good to me. Let's go ahead and add some motion. So I'll add a new keyboard sensor. Of course, we're going to be using WASD. So keyboard, and I'm going to add an actuator. We want to use motion, of course, with the cube selected. I'll connect those two. And we're going to use the W key. So I'll click on this button and press W to set up this keyboard sensor with the W key. And this is where I'm going to use a new type of motion. Up until now, we've used just simple motion. And when you have a physics object like a character that has either dynamic or rigid body physics types, you have a lot more options here. Because our cube has a character physics type, we have very few options. But that's okay, because we're actually not going to use this option. We're going to be using character motion instead, which tends to work a lot better. It stops your character from sliding, and it also works really well with the physics type of character. So instead of simple motion, we're going to go ahead and select character motion. And as you can see, the first thing you might notice is that we have jump as well. We're not going to add that in this video, but I'm sure you can figure that out. If you make a keyboard sensor to your spacebar, you can use this jump option and it'll work pretty good. Let's go ahead and use the W key though for our local y-axis motion. So local with that L, and we're using location changing. So it's local Y. I'll change that, and I think a good value is 0.5 on the local y-axis. Let's go ahead and try that out. I'll press 0 to go to my camera, and then P to play, and I'll press W, and as you can see, I'm moving around my world, and it's working pretty good. Let's go ahead and name these. So I'll press W to name that brick W, and I'm going to say move forward, and now I can collapse that one. Let's go ahead and add strafing left and right. Of course, in a 3D first-person shooter, strafing means stepping left and right. So I'll add a keyboard sensor. Strafing with WSD would be left would be A. I'll add a new motion actuator, and let's connect them. And we're going to use character motion again. and we're going to use local. I'll press 0 to get out of my camera view. We're going to use local negative x. So negative x, I'm going to say negative 0.5 on the x, and with that L darkened for local. Let's go and try that out. I'll press 0 and then P, and let's press A, and as you can see, I'm strafing to the left. Great. Let's make that A, and I'm going quite quickly because I hope that you're comfortable making nodes and connecting them and what this motion actuator does. So I'm going to say step left, and I'll collapse that. I'll add a new keyboard sensor. I'm going to name this D, and that's going to be D, so that key is assigned. I'll add a new actuator. I'm going to add a motion actuator. It's going to be a character motion, and of course we're going to move it 0.5 on the local x-axis. I'll make this window a little bit taller, and let's connect them. So as you can see, quite simply, we have almost complete controls for our first-person shooter game. Let's go and try that out. I'll press P to play. I can press A and D to step left and right, and I can press W to go forward. Let's go ahead and add backwards. I'm going to add a sensor for a keyboard, of course. We're going to use the S key for backwards. I'm going to add a actuator, a motion actuator, and let's connect them. And we're going to use character motion. And if you move backwards, let's go ahead and press 0 on the numpad to go back to our 3D view. We're going to use the minus local y-axis. The green, of course, is y. So y, and I think if we look at our move forward, we use 0.5, so we'll use the same negative 0.5 to go in the opposite direction of the arrow. So let's go ahead and press P and try that out. Yep, I can move forward, I can move back. Ooh, and I can fall off my game. Let's go ahead and go back to 3D, and let's scale that up maybe twice to make that really big. So we have a pretty well functioning game. We can look around, we can move or strafe left and right, we can move forward and backwards. Okay, I didn't say we were going to do it, but let's go ahead and add jump. I'll select the cube. Let's go ahead and name this. That's S for the S key, and this is backwards. I should move that, I mean move backwards, but that's okay. I'm going to add a keyboard sensor, and we're going to make it space, and I'll name this space, and I can collapse that. Let's go ahead and add an actuator for motion. It's going to be character motion, and I'll connect them. And I'm going to say jump with an exclamation mark there. That'll be great. Jump, and let's go ahead and try that out. I'll press 0 on my numpad to go through my camera view, and I'll press play, and I press the space bar. I do jump a little bit. Now if you're not happy with how high you're jumping, if you want to jump less or more, you can escape that, of course, and with your cube selected, I'll press 0 so I can actually see the cube. You can increase the jump force. So right now it's 10, I'll increase that to 30. I want to jump a lot higher, and I'll press P, and as you can see now I'm jumping a lot more. Okay, so that's how you jump. If you want to fall faster in your game, in other words, if I think I'm sort of floating like I'm on the moon, so I go up and it's kind of slow to fall down, I can increase the gravity in my game. How do you do that? Well, under the World tab in your Properties window, we have our options to change our gravity. On Earth, gravity happens at 9.8 meters per second squared. If you've taken high school, maybe grade 10 science or physics 11, you'll know that 9.8 meters per second squared is the rate of Earth's gravity. Well, I'll just turn that up to maybe 15, and so now if I play my game, maybe it behaves a little bit better. I'll press the space bar, and it falls back down again. It's hard to tell without anything in our scene, so that's really a complete first-person shooter setup. The last thing I want to do, and if you've stuck around to this point, I'll kind of reward you here. I want to add a texture to our ground and add some things in our scene to make our game look a little bit better. I'm going to add a checkerboard pattern to our ground. So I'll select the plane, and we need to add a new material to it. Now, if you're only used to using the old Blender render engine, in other words, if you've only ever used Blender render engine, you'll know how to add materials, and that's actually the way that you add materials in the Blender game engine. If you're only used to using Blender cycles, in other words, if you've only ever watched my Blender 2.7 video series, you'll know how to add materials using cycles. Well, unfortunately, the old render engine is still the way you add materials for the game by default. So let's go ahead and select Blender Game, because that's what we'll stick in, but I want to add a material, checkerboard pattern, to the ground. The first thing I want to do is I want to apply the scale of my ground. I scaled this ground way, way, way up, and Blender does not know that yet. So I'm going to go down to Object with the ground selected and go to Apply and Scale. And now when we unwrap this ground, Blender will know what size it is. So I'm going to go into Edit mode. I'll press Tab with the ground selected on my keyboard, so Tab. And then with the whole thing orange, if I don't know what that it is, I can go into Face Select mode and right click to select the entire face. And I'll press U on my keyboard and select Unwrap. Now if you're not familiar with unwrapping, in other words applying an image texture, I'll put a link to that on the screen right now. But the next thing we have to do is go into a different window. We need a second window called a UV image editor window. So I'll grab this little crosshatch area up here and drag it to the left. And I'm going to change this window type from a 3D viewport into a UV image editor window. This is where you can lay out a UV map of all the faces of your unwrapped object. So when I went and pressed U on my keyboard in edit mode with the faces selected, I selected unwrap. What that did is it looked at the shape of the object, in other words this flat plane, and it laid it out. That's what these 4 vertices, and that's what the edges, and that's what this is, the same plane laid out in this square area. That's great because I want to create a new checkerboard pattern. So I'll click on New. That creates a new image. We're still in edit mode over here, by the way. I'll click on New, and Blender can actually create new images for you. Right now, by default, it's going to create a blank image. I don't want that. I want a UV grid, which basically means a fancy checkerboard with numbers and colors on it. It's great. So I'll select UV grid, and I'll create an image that's 1024 pixels by 1024 pixels. That's okay for this simple example. I'll press OK, and it's zoomed way in, so I'll scroll to zoom out, and as you can see, it's created the UV grid, and the unwrapped floor is still there. I'm still in edit mode over here. So I want to save this image. In fact, I'll save it into my Blender file instead of saving as an external like PNG or JPEG image. I'll go down to this image menu, and a little star means it's not saved. I'm going to say pack as PNG. That'll actually pack the image into the Blender file, so I don't have to worry about any separate image files on my computer. Great. Let's go ahead and name this. So I'll call it grid, and maybe I'll save as image. No, I don't want to do that. I think it should be saved once I save my file. Let's go ahead and add a material. Now if you're only used to the Cycles render engine, this will seem weird to you, but first I have to go back into object mode. I'll press tab. If you've never textured an object in or added a material to an object in the old Blender render engine, you know there's actually 2 tabs you have to use to add an image texture. Let's go over to this material tab with the ground selected. I'm going to click on new. That should seem pretty familiar even if you're used to the Cycles render engine, and we can give it a color. So I can click and give it red. That's all good and great, but everything down here looks different if you're used to the Cycles render engine, or maybe you're used to it, I'm not sure. But to add an image texture, we actually have to go over to the next tab. We have to add a material first. In fact, I'm going to call this ground, and then with ground selected, we only have one material, so it's pretty easy. I'm going to go over to the next tab, and I'm going to create a new image texture or a new texture that corresponds with the selected material here. So you can kind of think of this tab as a subset of this tab. So if you only have a material selected here, you can add a texture, an image texture to it. So I'm going to click new, and I want an image or movie texture. It's that by default. I'm going to scroll down and find the image right here. In fact, I can just click on this little picture icon and select grid. And now we have an image texture loaded in. It has to use the coordinates that we created by unwrapping the ground. So if I press tab, the coordinates are this map here. I have 4 vertices and 4 edges, and the face is laid out to map so that this grid will appear on this flat surface as it does in this square over here. So under mapping, and by default we're okay, we don't have to change anything. It says UV here and not any of these other options. So all we did was we created a new texture. When pressing new, we specified what image, and then everything else should be okay. If I now press tab over here to go back into object mode and then switch my view into texture mode, it'll actually show up in our game. Now why isn't it by default? because we have a light in our scene. Let's go ahead and press 0 on our numpad, and I'll press P, and as you can see, we can see this in game. The reason why we are not seeing it in this view is because we have a light in our scene. If I press 0 and select the light and delete it, we can now see the grid. The light, it doesn't show up very well in this 3D viewport. It doesn't actually cast shadows like it should, so now we can see it. If you can't see with texture mode turned on or texture viewport shading turned on, if you cannot see the grid, that probably means that you don't, when you press tab with your ground selected to go into your grounds edit mode, if you don't have the image over here, it won't show up over here. When you press tab to go into edit mode and you press A and A to select all of your vertices, you should open your image with the grid laid out here. That's one of the little weird things about the old render engine or the game engine, is that to get it to actually show up in here, it's a little bit trickier than with the Cycles render engine. Let's go ahead and press tab to go back into object mode. Let's go ahead and press 0 to go back to our camera, and press P to play. As you can see, I'm walking around and it looks great. One other little tip is to use a different kind of viewport shading. If I press Shift C, I'll press Shift C on my keyboard so I can see my entire scene. Shift C actually puts your 3D cursor back in the middle of your scene. I'm going to add a new object. I'm going to add, let's say, a monkey head. I added it there. In fact, I'm going to move my character over, and I'm going to move my monkey head. This is Suzanne the monkey head. I'm going to move it on the ground, so I'll rotate it with the R key, and I'm going to change my gizmo back to global, and I'll scale this with the S key way up, so we'll have a big monkey head sitting on the ground in our scene. I want to add a material to the monkey head, so I'll go to the materials tab with the monkey head selected, and I'll click new, and I'm going to click and give it a big orange color. There we go. And I think it's too blocky right now, so I'll add under the wrench tab a subdivision surface modifier, and that'll make it all nice and smooth. I'm not sure which one the game render engine uses when you're playing, if it's render or view. That makes it more smooth the higher you turn this up, but don't turn it above 1 or 2. In fact, I'll turn them back down to 1 for both of them. So now, if I play my game and I press P, and then maybe I'll back up, that looks okay, but we're not seeing any shadows, and we're not seeing any definition in the monkey head. The way you can improve that, and I'll make a video on this in the future, is let's go ahead and add a sunlight to our scene. So I'm going to press Shift A, and I'm going to add a new lamp, but we're going to add a sun lamp. Sun lamps tend to work the best in the game engine. You'll see automatically if you have the texture viewport shading turned on that you'll get shadows in your game. And so I've moved the sunlight way up, and I'm going to go to the sunlight tab with the lamp selected, and I want to add shadows because we want to have a realistic looking game. So I'll click on shadow, and I'm going to turn the buffer type from simple to variant, which will actually give me better looking shadows. And so if I press 0 and play my game, we have a monkey head that looks more like a monkey head. It has definition on it. Maybe what I want to do is I want to make this smooth, so I'll select the monkey head, and I will make it have smooth shading under the tool section in our tool shelf. There we are. Now it's not casting shadows right now. If I press P to play and I move back, the ground does not have shadows on it. And why is that happening? Well, I think that's because, and I'm going to go back to my 3D view, not the camera view. I'm pressing 0 on my numpad. I'm going to select the lamp. Shadows are selected. Variant shadows are selected. But I need to change my viewport shading to a different mode. Now this is sort of hidden, and it's very hard to find unless you know it's there. Over here on the right side of my 3D viewport, there's this little plus. So if I press it, it opens up the properties panel in my 3D viewport, not to be confused with the properties window. And that's also the N key on your keyboard with your mouse in this viewport. If you press N, it shows that side, T, it shows this side. I want to go to, I think it's view? No, it's shading. And right now the shading type in this window is multi-texture, and that's fine, But when you're playing a game, you probably want to use the other option, which is GLSL. Now, I can't really explain what the difference is between these two types, but GLSL is much more commonly used in games. And once I do that, you can automatically see that I have that shadow on the ground now. With multi-texture, it looks like that. With GLSL, it looks like that. And if I press P now to play, I'm not looking through my camera, but as you can see, there are shadows on the ground. I'm going to press T, and I'll make this one a little bit wider, and I'll press 0 to look at my camera and play. So now I have shadows on my ground, and I have an orange monkey head, and it looks pretty good. And if I walk into it, well, the monkey head does not have a very good collision type, but it works pretty darn well. How could I fix that? Of course, I could select the monkey head. I could give it a better collision bounds of a box maybe. And so now if I press P, I can't bump into it because it's surrounded by a cube. That's going to be it for this video. Thanks for watching, and I'll see you next time.